found on page 58 in your textbook. You're also welcome to read through this in your online textbook. The title of our section today is called Land and Water, in which we're going to continue to study what makes up our Earth and the different physical features of our Earth that would influence the geography of where people live. The essential question for today is, how does geography influence the way people live? How does the land and water influence you and me on a daily basis and influence all the other people in the world, wherever they are and where those features interact? In front of you, you're also going to need your note page. It looks a lot like this. Lesson 3, Land and Water, set the title page. The essential question is listed right here, and then below are the 3 sections that we're going to read through. Now I want to preface what you're looking for in your notes as you fill this out, because then we can identify as we're reading what it is that we're supposed to be comprehending from that reading specifically. In the first section, it talks about land taking different forms. We're going to identify the different surface features of land. And if you recall to our geography terms video where you studied it in the reference atlas, all the different land features from the map and those definitions, some of these are going to come up and might be useful to reference back to that within your textbook in the reference atlas section. In this section, you're going to read about those surface features on land and those that exist on the ocean floor, because both of those, the surface and the ocean floor, are the crust layer of the Earth. As we've studied in the 4 different layers of the Earth, those features are based on 2 different factors: the elevation and their relation to a body of water. So we're going to take a look at all those different features, and you see here on the right hand side there are definitions that you need to match with and identify as those different landforms. So as you're reading, if you read across one of these definitions, you'll obviously understand in the context of the reading what that item is that you're looking for. There are 10 of those to complete, and then in the next section we're reading about the blue planet, studying specifically more about the kinds of water that our planet has. God uniquely created our planet to be the perfect distance from the sun to where we have the atmosphere and the warmth that our water isn't frozen. Other planets we've searched to say, well, where is water in the universe? Where could there otherwise be life? And we found nothing but places where it's completely frozen, if we find it at all. So we've been perfectly placed at this distance, at this location, to have life here, and water is what gives us that life. Now there are 2 kinds of water. We'll study the differences between those 2, and then where you can actually find those types of water in the different bodies of water on our planet. In this section, you're using your textbook to decide if each statement is true or false. Write T or F in the blank to this left-hand side. If the statement is false, rewrite it correctly. Now it says rewrite the statement, so I should see a full complete sentence written right underneath here if that statement is false. In the third section, after you've completed those 10 true-false questions, we're going to continue to study this blue planet and the water that makes this planet unique, water that gives us life, in the form of the water cycle. It asks you to use your textbook to identify 3 steps in the water cycle, and it has those definitions provided in which you would fill in the blank. Let's get to it. As you begin reading, land takes different forms. You're going to come to understand that there are 2 factors that influence what gives our land its identification or its features. The first is elevation. Remember, elevation is distance from what would be considered sea level, so how high something is or how low something is in comparison to sea level. And in one of the previous lessons I told you the story of how I traveled to Denver, Colorado. And I was there visiting some of my college friends. You can see us pictured here up on what is Rocky Mountain National Park. We're at the peak of this different mountain ranges, and you can see that there are no trees by us. As we're driving up, we're going through all sorts of forest that's behind us, and we get to the top of the mountain, and actually it's so cold up there throughout the year that the trees don't actually grow, and there was still snow there. That during that same day it was 90 degrees in Denver, and here it was probably 30 or 40 degrees at the top of the mountain, because that elevation, as you increase, it decreases the temperature. Elevation determines our land features based on how high it is from that average sea level, and in any place that you're studying, you're going to determine what that elevation looks like and how that would influence the people that live there and what they're able to do in those areas. Here's a picture of the map of Wisconsin, which has an elevation map or a topographical map to show you those elevation changes. The different colors show higher or lower elevations. Here we are down in Milwaukee. Now this yellow feature here is showing where this large city is, so that's not necessarily a color of elevation, but the surrounding area, the green around it, shows actually how low it is and how relatively flat this area is. Now there can be some types of rolling hills throughout the southeastern part of the state, but it's relatively low in elevation. You'd say, well, why is that? Well, anytime you're by a body of water, you usually have lower land areas. And right here next to us, it's not pictured, but this would be Lake Michigan. As you go to the western side of the state, you see these different kind of little branches that show a lighter color and then the green lower color. These are the kind of mountainous areas in this region, or rolling hills areas. I shouldn't call them mountains. Rolling hills area in the western side of the state. If you've ever traveled to La Crosse or in this region, there's a lot more topography, a lot more change in elevation. As you go northern into Wisconsin, there's even more change in elevation, and you're actually at a higher elevation because of this darker colors. So as you're studying a place, the elevation determines the types of landforms that are there. Are they flat? Is it hilly? Is it mountain? Now, a question to think about when you're studying elevation as it refers to the different types of landforms: is there any connection between the landscape and population? In Wisconsin, people live primarily in the southern portion of the state because here's where a lot of our larger cities are. In the northern part of the state, there's a lot more forest, there's a lot more land that's spread out, and there's more maybe a summer destination or vacation type of or recreation type of population that lives here, where a larger population is going to live towards larger cities. In other places, people live where they can settle and where they can survive. We said that 70% of the population lives near water. Here's a major city. This is Green Bay. Here you have a number of cities on the coast where the Lake Michigan exists, a number of cities where the Lake Winnebago exists through the Wisconsin River, and then on this side where the St. Croix and the Mississippi River exist. So you've got people that live near bodies of water, and obviously not living in huge massive mountains because it's difficult to live in mountains, living where they can actually survive and get those different types of resources from the land. The second feature that there is to consider when you're studying the surface features on land is the idea that the ocean itself has those same type of features. Now, a couple key takeaways from this section as you're studying the ocean floor and reading through this section. You'll sum it up by remembering that landforms are grouped by their characteristics. Plateaus and plains are flat, but a plateau rises above the surrounding land. Valleys are huge expanses of land with highlands or mountain ranges. Continents are the largest of all land masses, and the ocean floor can have plains, valleys, mountains, hills, and plateaus. That ocean floor, just like the surface above the water, has all sorts of features based on its elevation as well. And because it's part of the crust, that outer layer of the earth, that's why it has those different types of features. It's not just relatively flat. If you look here, this shows the different types of mountain ranges that exist underneath this blue, and it also shows what's called a continental shelf. Where these continents exist, where the land mass is above the water, you actually have into the water a number of miles probably from the actual shore, where this actually drops off and becomes a lot deeper. So near a shore there's a lot more shallow type of area, and then as you get further into the ocean, a lot of times it's a lot deeper. Even though there's massive mountains and valleys and things that you can't necessarily see on the top of the water, they do exist on the bottom of the ocean. Now, Mr. Shane doesn't really like to talk about the ocean because he's afraid of sharks. Even though he went scuba diving one time, the scuba dive instructor said, "Oh, don't worry, there's no sharks here." And then as we're swimming through the water, I can see that this guy actually has a knife on his ankle, and he's got a knife right on his chest on his scuba gear, just in case there was a shark. So I kind of freaked out a little bit. And then when I was down on the ocean floor about 50 meters. So I don't like to talk about the ocean floor because sharks are one of Mr. Shane's biggest fears. But you can see here in this picture, the ocean floor is somewhat flat in areas. Other times it can have large bits of elevation or change based on the land surface or the surface of that crust. Here's an example of a reef. It has all sorts of organic life and fish and coral that are living here, and that attracts obviously an apex predator to try and rule over what that biodiversity is in this region. Another example of the ocean floor having those land features is the Mariana Trench. It's considered the deepest part of the ocean, drops way down like a massive valley, and if you compare it to actually the height of Mount Everest would actually be underwater still if you were at the total depth of what this Mariana Trench is. So there can be massive valleys and massive mountains under the oceans, and we don't even know that they're there because they're obviously completely covered by water. Speaking of covering by water, our planet is 71% covered by water. That's why it's called the blue planet. And we're going to answer the question of what types of water are found on Earth's surfaces and where are those types of waters found. This diagram in your textbook, as you're reading through this section, talks about the difference between salt water versus fresh water. Those are our two types of water. Earth's surface is about 70% water, which seems like a lot, but how much can humans actually use of this water? This picture of all these water droplets shows us what we can actually use. The darker droplet is salt water. The dark blue droplet is water that's too difficult to access. It's actually fresh water for us, but we can't really get to it based on where it's located. And then the light blue droplet is what we can actually use as humans and as living creatures. Only 1% of the world's water can actually be used by us. 99% of the water in the world, 97% salt, and 2% is actually too difficult to access. That 2% is locked away a lot of times in what are polar ice caps, so in the North Pole and in the South Pole, or it's in underground, which is called groundwater. Crazy to think that all of human life, the millions and millions and millions and millions of people, and all of the animals and plants that need water to survive on just this 1%, besides obviously all the different types of fish and aquatic life that live in the ocean or in different types of lakes and rivers. 46% of American lakes are too polluted for fish or aquatic life. Lake Michigan once had a problem with this, and now it's been relatively clean in the last number of years since measures have been taken to reduce those pollutions. A lot of times near cities, water runoff from all the different streets gets into what would be the natural water sources, and that affects aquatic life. And this last fact here says approximately 1 in 10 people lack access to clean drinking water. That's unfortunate because there's so much water everywhere in the world. How can we not have water for everybody to drink just based on the circumstances of where people live and where that water might actually be polluted or contaminated based on human actions? Two kinds of water, sum it up. Earth's surface can be freshwater or saltwater. It can be contained inside of Earth's crust. That's called groundwater. That's again that hard to access stuff. The world's largest bodies of water are its 4 saltwater oceans. Sometimes people say 5. Those 4 oceans would be Pacific, Atlantic, Indian, and Arctic. If it is given the designation or the label of the 5th ocean, we'd call that the Southern Ocean, which is down towards Antarctica and the South Pole. 97% of the Earth's water is salt water, and water is used for anything that we're going to need to survive: drinking, irrigating crops, watering the plants, and different types of recreation. If you've ever gone swimming or gone to a water park, if you've ever gone to Wisconsin Dells, you've used water for that type of recreation. How many bodies of water can you name? Here's where you'd be thinking of that reference atlas page again. So rivers, lakes, streams, a delta, the mouth of a river, a channel, a bay, a harbor. All those different features are what you need to identify on a map or in the study of geography. Are there 5 oceans or 1? When people designate these oceans as different bodies of water, a lot of times they try to separate them. But if you look at this picture, all those bodies of water are connected. What's unique about other bodies of water, such as rivers or lakes, you can see actually where that water is by itself, alone and standing. Up here in what would be North America, you see the Great Lakes. Those Great Lakes are connected, but each one can kind of be designated as by itself. The Atlantic Ocean connects to the Indian Ocean right here. How do you draw that line, or where's that line drawn to say which ocean that you're in? Technically, all these oceans are just one large ocean, and we just give it a name so we have more of a specific idea of where those items are. Here's the Atlantic Ocean, the Pacific is on this side, and this side, as those are together in the globe. This would be the designation of the Southern Ocean here in Antarctica, and the Arctic Ocean in this location, with this being the Indian Ocean here. Last question: how does water affect the way people live? And what's it used for? Well, it's the way in which we survive, and then based on where you are and what water you have access to, it's what you're using it for. Obviously, cooking, cleaning, bathing, drinking are ways in which we use it to simply have our way of life, but other things such as recreation would be ways in which it's used as well, or irrigation if you have a garden, or if you're a farmer, you're using that to water your crops. The last section talks about the water cycle, and you're going to fill out the chart that shows this flow of water from one location to the next. We're going to get some help from NASA to help us illustrate and explain how this water cycle works on this huge, large scale. Read through this section and then watch the rest of this video to help create a better understanding with the visual of NASA.
is the fundamental ingredient for life on Earth. Looking at our Earth from space, with its vast and deep ocean, it appears as though there is an abundance of water for our use. However, only a small portion of Earth's water is accessible for our needs. How much fresh water exists and where it is stored affects us all. Nearly 2/3 of this fresh water is stored in the polar ice caps, snowpacks, and glaciers, making it inaccessible for long periods of time. The water cycle is dynamic. It describes the continuous movement of water on, above, and below the surface of the Earth, and the transitions from one state to another. Sea surface temperature, surface winds, and air temperature influence the rate of evaporation at the ocean surface. In the tropics, warm ocean surface temperatures support high rates of evaporation. Wind also increases evaporation. When the air's temperature is warmer, it can hold more water. While the atmosphere does not store a large quantity of water compared to the ocean, rivers, and lakes, it can transport water quickly from one place to another. Low-lying regions of the atmosphere with high moisture and strong winds can form atmospheric rivers to transport water horizontally. Clouds are formed as water vapor cools and condenses into droplets and ice crystals. Clouds and water vapor act as insulators in the atmosphere. Clouds help shield the Earth from the sun and trap heat from below. When cloud particles grow large enough, they may fall out as rain or snow. Under the right conditions, areas of precipitation can grow into large storms. As storms grow, they transfer heat vertically into the upper atmosphere. The migration of storms helps to distribute heat between the equator and poles, shaping wind patterns globally. How storms grow and intensify depends on atmospheric moisture, surface temperatures, and wind patterns. Precipitation is concentrated in some parts of the world and scarce in others. It can vary substantially from season to season and from year to year. Water that falls on the land surface as precipitation is stored within snowpacks, lakes, reservoirs, soils, and underground aquifers. Water availability varies from place to place and over time. The availability of water affects the type and abundance of vegetation, the primary source of food for animals and people. Extreme water cycle variability, unusually dry or wet conditions, impacts humans worldwide. Each year, hazards such as floods exact a costly economic and human toll. Most of the water that falls onto land remains stored there for weeks or more. Snowfall is stored as snowpack or ice. Meltwater and rainfall are stored in lakes and soils. Some of the water is absorbed by plant roots or drains into the water table. Eventually, the water will evaporate to the atmosphere or return to the ocean in streams and rivers, providing a source of nutrient-rich water that supports ocean life. Sensors on a suite of NASA satellites observe and measure water on land, in the ocean, and in the atmosphere. These measurements are important to understanding the availability and distribution of Earth's water, which is both vital to life and vulnerable to the impacts of climate change and a growing world population.